Okay, everybody. We're back. Double checking. Everything sounds good. So, what are we going to do today? I've got some things. Basically, I dried my PPSCF filament yesterday, all day. 8 hours at 100 degrees Celsius. I weighed it beforehand, and I showed you guys. We came in at 1,647 grams. That was before we dried it. After the 8 hours at 100 degrees Celsius, we came in at 1,631 grams. So we lost 16 grams of water, which I think would be 1% of the total weight of the thing, which I think is pretty good. And so that I took it out of the dryer last night at around 8 o'clock. I then proceeded to put it in a dry box, and then I waited again this morning. I didn't have like fresh desiccant or anything in there, so waited again this morning. It gained another couple grams of moisture, so it's certainly not it's not a perfectly dry box, but it's better than I think if I would have just left it out. So basically, what I want to do today is I want to build, just really quickly, I want to print a spool holder that fits inside of that dry box I have. So this is my normal spool holder for the big spools. There's two of these with little bearings. And these work awesome, but unfortunately, once I put these inside the bin, the lid can't close. It makes the bin is like just big enough to hold the spool. So I have some other bearings. I've got some bolts, and we're gonna print a simpler version of this. This was just a model I took off of Maker World or whatever, and this is nice because it can fit a different variety of spools, and I have some 5 kilogram spools that need to be wider. I have some 3 kilogram spools, and then obviously I have the small ones as well, but I don't really use these for the small ones. But as far as the dry box is concerned, I only need to fit the 3 kilogram spool. It's the only spool I really need to fit in there, because if I did a 1 kilogram spool in there, I could do this, but I also have the poly dryer. So essentially I just need to make a new version of this, but instead of 4 rollers, I'm just going to do 2. And it's going to be a lot simpler than this, but I need it basically I need these to be wider apart so the spool sits lower in the box. This is just slightly too high, so it doesn't have to be crazy, but it's got to be a little better. So that's that. I have finally put new batteries in the calipers so I can use that again. Here, let me grab the box. So this is my dry box. I messed up, and I didn't realize I had already melted a little hole in the top of this that the filament is going to feed through. I probably should have put a lid that didn't have a hole in it, but it's fine. I'm going to make this hole bigger. I'm going to put a little adapter for a PTFE tube in this, and then I'm going to go directly into the PTFE tube coming out of the printer. So that way I will have a seamless, I guess, kind of airtight route right into the printer. 1 second. Oh, constant distractions in this place. Constant distractions in this place. Anyways, we're looking at 14% humidity in here. Not ideal. 10% would be kind of the ballpark I'm going for. I actually bought a bunch of little humidity guys, hygrometers, so I can better monitor individual things. And the one I have in there is kind of huge and like unruly, so I want to, yeah, here we go. I'm decking this place out, folks. So we're getting 42% humidity right now. I'm gonna throw this in the box and just see See how it compares to this other one. But this will be a simple print. Yeah, it's already dropping. And then on top of that, what I want to do is I want to reprint that reverb. I'm going to redesign it entirely. I want to nail it. I want that to sound so good because I think we're so close, and if I can get that, it's going to make the song a million times better. So that's kind of the main thing I want to really focus on, and it's nice that I'll have the dry filament that we can print that out of once we get this spool thing going, and I think I can get this printed pretty quickly because everything's going to be pretty small and thin. So to start, let me measure. Actually, I'm going to keep that spool in the box. Give me 1 second. Oh, one more thing. Okay. So I've got a different 3 kilogram spool. This is PLA Pro, but it's the exact same size spool. So we'll use this, and obviously this doesn't matter if it's sitting out in the open. So to start, let's just measure the diams of this. We're looking at 9 3/4 of an inch, and width-wise, 4.5 inches. So let's pop into Fusion here. Oh no, God, there's a bunch of new things here that's different. I'm not going to recreate the wheel. I'm just going to do this the exact way I've always done things. So let's draw this on the front. And what did I say? 9.5 inches. Boom. And then we're going to extrude this. Wait, what is happening here? This is all different. This is all... This is different. Okay, I guess I'm going to create a new component. Call this spool. Oh my gosh, what is happening? Okay, this is weird. I've never seen this before. This is all new. I don't know what Fusion did. Anyways, but it's doing the right thing now. So 9.5 inches, and we're going to extrude this 4.5 inches. Boom, there's our spool, right? So the key with this is we basically want this to sit as low as possible, right? So we can essentially create a 9.5 inch box, 9.5 inch box, right? So we can imagine that this is our box, but our box is actually a little bit deeper than this. What do we have for depth on this bad boy? Okay, so we're looking at about 10 inches, right? So we have an inch, or we have a half an inch. We have a half an inch room here. So we can go like this, offset this, 0.5 inches. I actually have more because the lid kind of bubbles up a bit. So we probably have about an inch, but I'm going to pretend this top line's the lid, not this top line. That one's just whatever. So I want this to sit half an inch off of, even less. Okay, you know what? Let's do it less. Let's go 0.25 of an inch, right? I think we can manage that. think we can manage that. So our bearings, classic 608 bearings, real cheap ones, but they roll nice. And we're just going to measure the diameter of these. 22 millimeters. 21.99, but 22 millimeters. Because there's going to be a seam. So we can draw a circle at 22 millimeters. Boom, that's our bearing. And then we want to basically do let's do a 2 millimeter, right? So 2 millimeter thick wall will be 26 millimeters, right? Because it's, we're talking diameters here, right? So alternatively, I could have just done an offset. 2 millimeters. And just to double check my math, 26 millimeters, perfect. So that's good. Now we can tangent this. Let's tangent this to this. Boom. And let's also tangent this to this. Okay. So that's going to get us perfectly in line, and we're going to mirror this here. Boom, boom, boom. We're going fast. We're speed running this, right? So now if I extrude this and this, we want to go 2 sides. We'll make this a little bit wider because my bolts here, they're 6 inches long. I just went for kind of like extra long. But how long is it between the thread? Because that's where it matters. So we've got we've got 5 inches there. So I need these things to be 5 inches. So we want to go inwards. If we go 4.5 inches in, that's the same as the spool. But to get 5 inches, we want a half an inch longer. So let's go 4.75 inches that way. So we're getting a 1/4 inch extra on each side, and that should give us 5 inches. And we're going to go 2 sides, and we're going to go this way. We're going to go 0.25 of an inch, and that's going to be a new body. Okay. So we're going to call this roller. We're going to call this spool. So our bearings are just going to sit right in there. And then I want to create a little feature that sort of holds the bearing in there, a little bit proud of the roller. So once again, we're going to measure this, but I'm going to measure the thickness of this, 7 millimeters. So let's have it stick out 1 millimeter, right? So I think the best way we can do this is construct this, and we can go -6 mils. Boom. Create a sketch here. And this is where I always kind of get a little bit. I always end up going a little overboard because I want to print this without supports. I love to just print everything without supports is the goal. So all we need is the tiniest little kind of weird what's happening here. Oh no, it's not weird. Makes sense. So let's do this 21 millis. Finish. And we can extrude this back -2 mils. Boom. Let's get rid of our sketches here. And then I'm going to just fillet this. There. That's going to create a little bump that the bearing can't go past, and then that should also print without supports, ideally. Don't know if it's good. It should work. It's only a 1 millimeter little feature. I think that'll be fine. Now, we want to do the same on the other side, but let's just do it this way. Let's do a mid-plane between that face and that face. Okay. And then we're going to mirror this body with this plane. Boom. Join them. Nice. So that's our new roller. So I don't need to remodel this because I'm just going to print 2 of these rollers. So I'm going to call this official roller. And this is just a demonstration roller. Okay. Is this all making sense? I hope so. So now all we need to do is create little walls that bolt into this. And just for the hex of it, can we find a 608 bearing? Whatever. We don't need to do it. We don't need to do it. We have the measurement. Ignore that. Ignore that. Okay. Now we're just going to create another sketch on this surface here. And we're just going to do a real dirt simple. Oh, I got to turn my sketches on so I know. So this is the floor here. So we can use that. And we're just going to go and project that part actually. And all I need to do is a box like this. Boom. And I did it this way so I can just mirror this box. So it's the same distance. Okay. And then I need to know the diameter of these 5/16 bolts. They're 5/16, but may as well get the millimeters, and then I can upsize it just a tiny little bit. So 7.8 mils. So we may as well just do 8 mils. Little wiggly's fine. 8 mils. And this is going to be super simple. In fact, if I want to do this as quickly as possible, I could just laser cut these parts. I'm going to print them. Yeah, print them. It's going to be probably just as fast because laser cutting is a little bit more of an involved process. So let's finish that. And we will just extrude this. And we'll bump it out maybe, what, like, do we want to do it 3 millimeters thick? 3 mils thick is nice. I think that's a good thickness. We'll do new body. And then we'll call this wall. Right? And we're just going to print 2 of these. This is literally it. May as well make it like kind of nice. Throw like one of these on there. Okay. Boom. That's it. And that should work. Oh, you know what I'm going to do actually? This is kind of like a little fancy thing I'm going to do. So now in a perfect world, there's no gap between the roller and the wall, but in reality there will be, and the edge of the spool could potentially fall into that gap. So we want to prevent that from happening. So I think what we're going to do is we're going to isolate. Wait, why can't I isolate this? Weird. I thought I could isolate. Anyways, we're going to go like this. We're going to create a sketch on the back side. I'm going to offset. This is what's kind of annoying about Fusion is like I feel like I shouldn't have to project if I'm sketching directly on there. But anyways. Oh, that's why. So we're going to project this. We're going to come in 2 mils. And then I'm just going to extrude. Let's turn off all these other sketches. Extrude this 2 millimeters. There. See? So now the little gap, the spool will run into this edge before it runs into the potential gap that's going to be in between here. And I think that's going to be perfect. So I also am going to need some washers to space this out because I'll be able to tighten this. But that's it. That's literally it. And we're going to print this on the P1S because I've already got PLA loaded on that bad boy. So let's go and save as mesh. Okay, and I'm going to save it to a different folder. Spool holder for dry box. Save. Oh, I did the wrong roller. Save as mesh. Official roller is what we want. Save. Wall is what we want. Save. Okay. And then we're going to go to our Bamboo Studio. And we are going to add. Oh, I did this in the wrong thing. Why is there nothing in here? What is happening? You guys saw me just do that, right? Oh, failed to translate. Why? Okay, let's go to just desktop and spool holder for dry box. Maybe it can't do 2 folders. Official roller. What is going on? Do I gotta save this? See, this I don't understand what's happening. It's saying this is unsaved. Okay, let's break this chain. Why is it saying unsaved? I'm so confused. Unground from parent for sure. Okay. Don't know what's going on, folks. But now that I'm saving this, spool holder for dry box, done. Okay, now let's see. Official roller, save as mesh. Okay, save. That seemed to work. Beats me. I don't know what's going on with this. I don't like this new. I mean, I'm sure it's better in some way, but I don't know why. Anyways. Okay, I'm going to copy and paste this, and then we're going to arrange everything. Boom. Now, is there a way I can add a brim to only the one thing, I think, maybe. Brim, outer and inner. Yes. Brim, outer and inner. Yes. Let's slice this. 2 hours, 12 minutes. It seems like a long time, but for this, but that's fine. You know what? We don't need 9 walls. This is using up way too much. Let's just do 3 walls. Because that's like, what was it using? Like 100. Huh. Oh. Okay, and then we only need 2, 2. There we go. I mean, we only knocked off a couple. That's fine. Print plate. Send. Let me just double check that I got everything off there. Okay, we're good. I've been having a bit of issues with bed adhesion on this printer. I'm just going to add some spray paint to the bed quickly. Okay. That is done. So, let's jump back to our reverb because this needs to be better. And I've experimented with a few things, and I think I know what we need to do. First thing is that this cup ends up resonating. It has a dominant resonant frequency, and so it will resonate way harder on certain frequencies than other frequencies. And what I've noticed is that despite being able to tension the spring at, you know, a pretty wide range of tension, it always kind of still has some specific dominant, it always has the same dominant frequency, and it sounds like it's the frequency of the cup itself. So I need to make the cup better. And I'm not 100% sure how to do that. And this is what's really interesting about instrument building in general, because, you know, when you think about the soundboard of a guitar, so that's just the big flat part of an acoustic guitar. So, on an acoustic guitar, this is the soundboard. And these are designed, they have braces and structures on the inside, because if I believe if it was just a solid sheet, first of all, it wouldn't be strong enough. The braces allow you to do a nice thin piece of wood that resonates a lot better. But each of those braces are tuned specifically as well, so that this guitar isn't picking up one specific frequency more than the others. Because if it did, then, you know, you could be playing it and different chords would be significantly louder than other ones, and other ones you might even be completely dead. And that's kind of the experience I'm having with this, sort of the experience I'm having with this cup. So I need to maybe add some braces to the cup to try and kill specific frequencies while also letting it capture the sound. Because if I did... it's too uniform. I think that's the issue, is this cup is just like too uniform, and I want to make it want to make it less uniform. The other thing that we could potentially try is, I don't know if you've ever seen a megaphone. Sorry, give me 1 second here. Okay, let's go megaphone. So a megaphone uses kind of a layered, or it's like a cone inside of another cone, and it essentially elongates the path that the air has to take to get... let me see if I can find a better picture of this cross-section. Okay, yeah, here we go. So, yeah, when you talk into a megaphone, what you're doing is you're actuating a tiny little membrane. And then that membrane comes through this pipe here, this little pipe, bounces off this cup, which bounces off this second cup, and that's how it's... This is impedance matching, right? So you're taking this tiny little movement, and you're allowing the air that it's pushing to expand and get bigger and bigger, and essentially that's how it amplifies sound. Mark Rober has the best video on this. And I wish I had watched it a long time ago, because impedance matching is something that is integral to sound design, and I never understood it at all. And I still don't. It's still kind of weird to me, but it works. And so I'm wondering if I can sort of use this sort of technology. So instead of just having a tiny little, we can pretend that this is our speaker cone. So this is the cone of the actual speaker that we're going to be putting the device up to. And you can imagine this first path of air is our cup. And right now the cup just ends here. And so we're getting a very direct line. So I'm wondering if I instead print a cup that kind of expands like this. It'll allow the membrane that's on this side, or the bottom of the cup here, to be a lot bigger, which will move more significantly. But what that will also do is it'll also give me a platform to mount more springs. And this is the second key to our spring reverb, is we want to print a few of these springs that are totally different. And so if we can manage to make the cup resonate a little more evenly across the frequency spectrum, the spring will still have, an individual spring that is uniform like this will still have a dominant frequency that it will want to resonate at. And so what we can do is we could try springs that vary throughout the spring, but then we can also add just more springs. And I think spring reverbs in general, let's see actually. Sorry, it keeps opening. Megaphone cross-section, here we go. Yeah, spring reverbs in general usually have multiple springs. See that? This has got multiple springs here. And look, they're like attached by other individual springs. So it's a lot more, it's not like a lot more complex. It's just, it is adding complexity by having different variety of springs in there. Like this one's got 3. I'm thinking 3 is kind of a nice option for us. So that's kind of interesting. Look how many springs are there, and then they've got some that are even dangling up. So we could try doing that kind of thing too. So I want to make a system that is modular. Like everything I do with this project, I like to make it modular so I can test multiple things with the same sort of layout. So I don't have to keep reprinting a bunch of stuff. So, all that being said, let's do this. Let's start with a 3-inch cup again. But this time I'm going to make the walls a little bit thicker. So let's go maybe 3.25 inches. Boom. And then we're going to expand this cup. So let's finish that sketch. I'm actually going to start a new project, I think, because there's so much going on. Like, it doesn't look like it, but there's so much going on in there that it's kind of driving me crazy. 3-inch, 3.25. It was bogging down the drawing stage, so I wanna make sure I'm doing this better. Finish that sketch. We're gonna construct an offset plane. Let's maybe make it 4 inches. And let's go with maybe a 5-inch circle. That seems like a lot. Let's go with a 4-inch circle. And then again, we're gonna go 4.25 inches. Boom. And I'm gonna loft between, oh, you know what? With lofts, I have to go like this. I can't. Oh, we're gonna have to do a shell. What do we want to do? 0.25 inches? Oh no, 0.125. Okay. And let's clear the bottom of this by going like, no, it's not gonna let me do that. Okay. I'm just gonna extrude it then, I don't care. The other thing I was thinking about doing was actually scanning in my speaker so I can create a TPU sort of form that fits directly over top of the speaker. But I don't think I need to do that yet. I want to try this out first. So we have that. And then I want to create another offset plane here. And I want to go down maybe 1/2 inch. And let's make this 4.5 inches. No, let's make this 4 and 3/4 of an inch. Okay, I guess we're making this 5 inches. Ah, I did it again. 5.25 inches. Boom. And then up here, we're going to go with like 7 inches maybe. Let's go 1 inch up. Boom. 7 inches. So this is going to be a big boy. This is going to be a big boy. Okay. And let's turn our sketches back on. Let's hide that. Let's hide this body. So this is, we're going to call this initial cone. What just happened? Okay, we're going to hide that. We're going to loft between these two now. Boom and boom. Okay, and we're going to create a shell. 0.125. Oh. 0.125 inches. This might even be too thick. Maybe let's do half of that. Let's do half of that. What's half of 0.125? Wait, how many mils is this? 3.175? Let's just do it 2 mils. Or 1.5 mils. Right, and we're going to add ribbing and stuff. So we got these, like that. And I think what we can do is we need to create a surface that this connects to this that will print properly. And I think just to do that, we're just going to go and hide this, extrude that portion straight down. What did I say? It was 0.5 of an inch? Yeah. Boom. Okay. Oh. We wanted 0.5 of an inch minus 2 mils. And then we're going to sketch on one of these face. Oops. That is not what I meant to do. Let's go pretty significant with that. Finish. God, I'm such a messy designer. Don't know why I got thicker here. So I'm just going to extrude that down. I'm not really sure what happened there. Okay. We're going to create a circular pattern here, and we're going to go with features. This is a feature. Our axis is going to be this axis. And how many we want to do? 10? 11? 12? Oops. Oops. 13, 14, 15, 16, 17. Let's go 17. Boom. Right, and then when we go like this, and then we can combine these two. Boop, 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 boop. Okay, so, oh, shoot, I just realized this isn't going to work because I need this cone to stick out further, but we can actually just go like this. Well, I'm going to make that 0. Okay, there. And then I still need to make this. Oh. Oh. This is getting really convoluted because now I need to... So here's the issue, right? The speaker, I didn't think about this. So the speaker is going to be sitting right here blowing into this tube. And now it's going to bounce off that wall, come back out this way. And then somehow I need it to go back out this way. there's no way I'm going to be able to print that. So let's extrude this up 1 inch just to be safe. And then I want to basically create a lid. And then I want to expand this even further. So I need this to come out again. So this thing's going to be ginormous, which I'm okay with, I think. I think I'm okay with that. What can I do? 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 And is this going to be weird? Like, is this going to basically just bounce right back into the speaker? I think that'll be okay, to be honest. I don't think there's an issue with that. Anyways, let's just keep modeling. Let's just keep on trucking along here. So we want to go with maybe, what's 9 inches look like? 9's good. God, this thing's going to be ginormous. And then off this platform, let's go with another 0.5 inches. Choom. This is going to be like my whole print bed, which might be a bit ridiculous. And then we are going to create a loft betwixt these two. So I need to do a loft betwixt these two. Okay. And then we can make this a shell as well. Make that 1.5 mils. Boom. And then when I bring these pieces back on, that works good. And then again, we're going to want to do some holes around the edge of this. So let's sketch again here. Let's project this guy. Let's project this whole body. And let's do a 2-point circle. So I know I want to start like there. Come up, we'll go 25 mils. Finish. Hide the initial cone. We want to extrude. Let's get rid of that. Let's get rid of that. Boom. Okay. Create a circular pattern of features around this axis. And let's do 20. Nice. Okay. So these can combine. Oh no, I'm not going to combine these because I actually want to be able to print these. We're going to get rattling. We're going to get rattling for sure. We're going to get rattling for sure, which I don't love. We're going to get rattling for sure, which I do not love. Now I have printed a bunch of this stuff already, like something this size with my drums. Let's try something here. Let's open up new kick drum video. Oops. Shouldn't have seen that. Well, it doesn't matter. That's where I'm headed with the new kick drum. So we don't want a new kick drum video. We want mini massive kick drum. Oh, yes. Okay, so I have to save this and call this spring reverb. Now, the reason I'm doing this is because I'm going to try and just reuse some of the parts I have here. So, specifically the rim. And, in fact, I have, yeah, this. I want to get this over there. So we're going to insert derive. And we're going to find our mini massive kick drum, select. Oh, it's smaller. It's significantly smaller. That's smaller. Okay, I have my other kick drum. So let's undo that. Let's insert a derive from our other drum that we did. Guitar for 3D printed song. I think I did the drum. When did I release that last video? It's kind of like midway through 2025, wasn't it? Hmm. Drums and drum parts? Yes. So let's take this. Okay. So we can use the shell I've already designed, and I can print a new skin, drill holes, or print a new skin with little holes that I can attach springs to. Okay, this might work. This might work. So let's get rid of the loft we did. Let's open up our sketches here. So we're going to get rid of this sketch. And we're going to create a new sketch here. I'm going to project just this circle. Right, we're reusing. I like that. Finish. And then we're going to loft betwixt this and this. Why didn't that work? We're going to create a loft betwixt this and this. There we go. Oh, I did the wrong. Didn't I? Yeah. Okay, so we're actually going to create a new circle. We're just going to offset this by 2 mils. Or no, by 1.5 mils. Boom. Finish. Get rid of those, get rid of those. Get rid of that. 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 Get rid of that delete that, delete that. Loft between these two. Boom. Nice. Create a shell. .5 mils. Nice. Okay. And then we can just extrude this guy. No. Let's get rid of our sketches for a second. We can extrude this guy up to here. We can hide that body. We can join these two. Okay. So what do we got here? So we're going to be able to stick our rim on there. Nice. That should just fit on there kind of good. And we have that, and then we have that. And then I want to split this body with this tool body. I'm going to keep tools, okay. And then this one we can remove. Boom. Great. So theoretically, okay, and then I have to minus this. So we can press pull this. Minus 1.5. Right, and then when we opacity this, that should line up perfectly. Yes, so that lines up perfectly. So we've got speaker blows into here, bounces off this surface, comes up through these holes, bounces off this top surface, and then comes down and through into our shell. Now I'm definitely going to get vibrations here. So I'm 100% going to get vibrations between this edge and this surface. Don't like that. Can I print this all in one go is the question. Can I print this all in one go is the question. So let's get rid of that for a second. Let's turn our opacity to like 70 so I can actually cut. Oh, oops. Will this print in one go? This part is going to suck. But I kind of want to try it. I kind of want to try this. Especially if I extrude this forward that much. I think I might try printing this in one go. The bridging here is going to be crazy, but it might work. And what that'll do too is that'll add a roughness to this that will break up any standing waves, I think. So let's try it. Let's combine all these. Boom, boom, and boom. Oops. Combine with that, and with... What? I can't do that? Okay. Okay, that's one piece. Boom to boom. Okay, so this is all one unit now. And I guess we can add some fillets. Let's go just half a mil more. Join this. this crazy? Feels crazy. It feels crazy, but I think this could work. You know what I mean? So let's get the opacity to 50%. So yeah, sound comes in through here, goes in here, comes through these holes, bounces around, comes up, comes back down, and out the front. This is going to be a massive print. I think this might be a little crazy, but let's try it. I want to try it. I want to add some more fillets here and here. 4. Let's do 3. Let's make them a little bit smaller. Let's add some more fillets here and here. Let's go 2. And let's add one more fillet around this inner edge. Oh, something wrong happened here. Okay, let's extrude this by 0.1 mil. Why is it doing that? Oh, it's not touching. Okay, annoying. How do I grab that to extrude that? Split this whole body at... No. God, this is annoying. Why didn't that connect? Let's go before we connected these two. Oh, wait. Okay, so we've made that a body now. And then let's pull this over. So what's messing up here, folks? That we can we can delete this. So we don't need that anymore. Let's delete all these. Okay. So this is all one body again. What is happening? Nice. Okay. Nice fat fillet there. I'm so confused. It's so hard to see. I wish I. How do I do a cross section? Let me look this up. Go to the inspect menu, select section analysis, and choose a face or plane to slice. Nice. Okay. Okay, this is awesome. So now if we do fillets. Oh, this is such a huge new skill. This is huge. This is great. In fact, let's turn the opacity back up to a hundies. Oh. Oh, this is so great. Let's go 2 millis there. Actually, let's do 2 on this side as well. 2 millis there. Okay, so now you can really see, right? Sound will come into the speaker here. It'll bounce through here. It'll bounce through these holes and come out this surface. And then when I have this on here, it'll connect with my existing drum shell, which I can print a skin really quick. And then that skin should vibrate like a mofo, ideally. So we can try that. Oh yeah, okay. And then once the skin is on the front there, now that's just where it's getting started. So once we hit the skin there, we need to create a chamber, which will have a bunch of, which will be able to tension a bunch of springs betwixt. And then on this end, I need something that I can clip my contact mic to. And this should get us some fat reverb, I'm hoping. So, let's go with that. I'm going to print this. How do I get rid of the section analysis? Ah. Nice. Okay, let's do a little filly up here as well, just for the hex of it. Okay, so this is a giant. This is one of the biggest prints I've ever done, I think. think it's worth it because this could make or break the song. So I'm gonna call this speaker megaphone. And we can go here. We can go to our H2D. We can go to our H2D. We can clear the build plate, and we can add this bad boy. Slice plate. How big is this? How big is this? It's gonna be an all-day print, I think. 7 hours. 377 grams of plastic. Is this bridging going to be ridiculous? So I can't do... So this is a problem, see? Oh no, it's doing it right. It's doing it right. See, it's doing... cross things. I'm not going to make it concentric. I'm going to make it monotonic. I'm going to make this monotonic. Slice this bad boy. This is a big test. This is a big test of this printer's capability to bridge this. Should probably do monotonic line, actually. I think that's going to go over the things. Let's see. Let's try it. I don't know. So I got to load in some PLA. I'm going to load in my big... Okay, I'll take you guys with me on my phone here. So dirty. Okay, it's going to freeze for a second, so let me actually just do this off here. So, yeah, we're going to print this. It's going to be a... Gosh, that's going to be a big print. 7 hours. I think we can... My other camera's froze. Why is it being like this? Sorry, I'm just going to reconnect all this nonsense. How do I do this again? This is gonna be nuts. If this doesn't work, I will be very upset. But that's what this is all about, right? Woohoo! Okay. Okay. Yes. Oh, it's so zoomed in. Hang on. Learning all these little tricks of the trade with this streaming stuff. Gotta go with iPhone. Is that just how zoomed in it is? That seems like crazy zoomed in. Maybe it's fine. Nah, that's way too zoomed in. What is going on? What is going on here? I think that's way more zoomed in than it usually is. tricks of the trade did not work. How come? Well, we're going with it. We are going with it. Let's go grab some filament. Let's go grab some filament. Yeah, I can do right nozzle. I don't have my AMS set up right now, so I'm gonna get my printer set up first. So we're gonna load that. We're gonna go grab a nice big juicy roll. I got these big boy rolls right here. Let's do black. Thank you, Polymaker, giving me the materials so I can actually test this crazy design stuff. It's ready to go. And again, we got our little spool holders here. Oh, actually, darn it. Stop. I want to use the left nozzle, actually. So I want to edit this to PLA. I want to load PLA on this. This is thrilling content. Let me bring you guys over here. Look at that fire going on outside. A lot of smoke. Okay, so let's load this. Heating all the way up. I guess it's got to melt the previous filament that was in there. Why is this so zoomed in? This is weird. I don't like this. There's our little pyro right there. What's up?
Filming it?
Yeah. See? I was filming your crazy little fire experiment going on out there.
Yeah, it's really windy.
Yeah. Oh yeah, there it goes. There it goes.
It's not an experiment, it's a production line.
You're producing things.
Producing charcoal.
What are you doing? Okay. So now we should be seeing filament coming out of this. I did not see it. There we go. Filament extruded, continue. I'm about to do a 7-hour print. About to do a 7 Alsies. So it's gonna be one of the bigger prints I've done. Probably the biggest on this printer, I think. The biggest thing I've printed on this printer so far. Okay. should be good to go. Oh no. Okay. Okay. Just give me 1 second. Okay, good. Good. So once that's ready, I have to sync this info. Continue to sync. Let's overwrite. Okay, and we gotta just change our filament over to... Why is it giving me right nozzle? I want to do left nozzle. What? Don't fully understand how this works. Why this grouping? Regroup filament. Okay, let's just... Okay, there we go. And... Oh! 4 hours and 26 minutes now? Oh, that's right, because I had it on PPSCF before, so it's actually going to print a lot faster. And we have a 0.6 nozzle, so it's going to print even faster, so we're good. This is only 4.5 hours. Holy shit, 395 grams of filament, though. Let's do it. Sending. Should I have done a brim on this? No, it should be fine. Should be fine. Okay, so I guess we'll be back. I'll work on some music, and then we'll come back to design the whole spring section of this once we're closer to the end of this, so that I can just print it right when this is done. And